Hi, this is Mr. Barron. What I'm going to be showing you is problem number 1 from the Isotopic Abundance worksheet. On this worksheet, what you're going to be doing for problem number 1 is calculating the average atomic mass. Now, all the problems are similar to the one that I'm going to work through with you, which is number 1. And I want you to do 2 and 3, and number 4 will be the advanced question. So, let's begin. First off, we're looking at two different types of copper. We have copper 63, which I am writing out the symbol for. And then we also have copper 65, which I'm writing out the symbol for. All right, the given information tells you that the very precise mass for this copper is 62.9296. And then it says it has an abundance of 69.17%. So, to be able to calculate the average atomic mass, what you're going to have to do is you're going to have to figure out what this percentage means. This percentage is the percent that all of the copper atoms on the planet, out of all the copper atoms that you ever look at in a sample, 69.17% of them will be copper 63 with a mass of 62.9296. Now, for copper 65, the more precise mass is 64.9278. And out of every sample of any copper you look at, 30.83% are copper 65. So, to figure out the average atomic weight, what you have to do is you should multiply these two numbers, the percentage and the actual mass. So, let me show you my math. I'll take the 62.926 and I'm going to multiply it by the percentage. But remember, you need to move the decimal 2 spots to the left when you multiply, so it's 0.6917. And I will get a mass number for that. And then for the other one, I'm going to take the mass, 64.9278, multiply it by the percentage, which is going to be 0.3083. Now you're going to get an answer for both of these, and then what you want to do is you want to add them together. So let me get out a sheet where I will do this calculation. 1 second. And for number 1, you may have even typed it in faster than me. It's 62.926 times 0.6917. Enter. Oops, there's a typo. It shouldn't be a 2 there. And the answer that I get, rounding to sig figs, 4 of them, is 43.53. All right. Now the next one, 64.9278 times the percentage, which is 0.3083, and then I get a mass, which is 20.02, and I'm rounding again to the correct sig figs. So now I have to take the 43.53, add it to the 20.02, and sure enough, I end up with 63.55. And that's the average atomic mass for copper. Sure enough, that's what you see on the periodic table. And that's how those numbers in the periodic table are calculated. They're calculated from the percent abundance that they exist in any sample that you look at. If you have any other questions, please see me during tutoring. Thank you.